In the last lecture, we introduced this idea of coupling. And so with coupling, what we're talking about is the strength of connections between modules and subsystems. Now, with the term strength, we kind of have this idea of a positive connotation. However, with coupling, we don't want this strength. We want a weakness between models. We don't want modules, and subsystems to be tightly coupled together. And so when we're talking about coupling, we mean almost like they're depending on each other. So for example, if we had a little set of modules and subsystems here, let's say there's just this sort of link and chain like so, and as complex or non-complex as your program is, we might have a section that is tightly coupled together. And when a section is tightly coupled together, that means that if we make a change here, for example, we're going to then have to go to this file and make a change, 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 etc., until we have basically everything changed so that it makes the change up here actually work. This has a whole bunch of downsides. The first one is just time. It'll take us time to figure out what exactly is coupled with this, usually through trial and error. We run the program, it says, oh, there was a break here, so we go change it there. Run the program again, there was a break over here, go change it there. If you have better documentation, maybe a little bit quicker, but a lot of times you kind of got to go through that break and fix. The next part is that it's just going to take basically the ability to maintain the program and decrease it. Because now when we make this change, maybe we made all of these changes, but we forgot about this case up here. And this case only operates, maybe once a month. Maybe it's some weird code that is like a server thing that operates once a month, and we forget to change it in here. So we go through all the tests and stuff, and it's looking great. And then in a month, we have this giant bug that comes up, and we don't know where it's from. Well, it's because they're tightly coupled together. It's because of this change that this happens. And it's even worse when we get to something like this, where it's actually down here is where that problem is. Because now we have to think, well, what did we change? Maybe we only are looking at these two files. We're like, we didn't really change much here. Oh, it was actually this major change up here that caused this cascading error. So tightly coupled programs are generally bad. You're not going to really get to the point of no coupling, but you want to try to get it as loose as possible. So with tight coupling, we have the idea of shared variables and control information. So all of this over here is the idea of control information. So we have these methods and classes that are all talking directly to other modules, or all controlling directly other modules. So changes in one will require changes in all the others. And then if we have the idea of shared variables, that's where we have this sort of giant list of variables, and each program on the bottom is using those variables. So if we make a change here, there's a lot of times we're going to actually have to make changes in all of the bottom files as well. And this structure can actually be beneficial in some situations. It can help reduce other areas of problems, but it might also create problems. And that's why this whole idea of design, we have this sort of balance that we have to draw. There's nothing that's going to be perfect, so we have to figure out what's the most perfect that we can get it, what's the most optimized we can get it, and that's the direction we have to head. And then state decentralization creates, should only be one C there, creates loose coupling. So what we mean by that is state decentralization is where we have sort of these little segments here. Maybe these two are coupled together, but then we have another section where these two are coupled together, and et cetera, et cetera. But overall, we don't have the entire program being coupled together in every which way. We have almost these tiny little states all doing their own things with little communications in between happening. And that helps us again with the whole debugging and stuff like that later on. So in the next lecture, what we're actually going to be talking about is we're going to be talking about the 3 levels of coupling. And that's going to be tight coupling, medium coupling, and then loose coupling. And then there's little categories in each one of them: content coupling, common, external, control, data structure, data message, and then none. And again, like I was saying earlier, none is pretty impractical. There's probably almost no applications that'll use no coupling. But we want to be able to go through all of these steps so that we can look at a program and understand how coupled is this program, how tightly knit is it, and is that good or bad?